Okay, guys, once again, I welcome you to my lesson for today, where we'll be looking at trigonometry. So, as I've explained, guys, I'm just going to quickly take you through a very short and quick revision of what we have done so far. So, remember, we are still on trigonometry, and we covered most of the information for grade 10, of which also grade 11s and 12s were invited, which serves as a revision for them. So before I even start, guys, I want to tell you something which I've always been saying, and I think it's worth it to also mention it again in this lesson. In my case, I wasn't that learner who was smart in class. So after realizing that I've actually not covered a lot of things when I was in matric, I had to start from grade 10, 11, while I was still in grade 12. So in short, I will elaborate this on another lesson. So in short, guys, I did my grade 10, 11, and 12 in grade 12. So that's why I was able to pass with distinctions, ladies and gentlemen. The reason to that is because I've noticed that most of you guys, especially those who are in grade 12, you tend to ignore information for grade 10, 11, and assume that you have done or you've passed that stage. Mathematics and physical sciences, guys, it doesn't change. Even when you get to a varsity, it doesn't change. It's one and the same thing. So you just need to make sure that your basics are right and strong. Just imagine if you build a very beautiful house, but the foundation of that house is very weak. You can imagine what's going to happen when they construct the roofing. It's going to collapse. So just make sure that if you're in grade 11 and 12, you attend my grade 10 lessons. If you're in grade 12, you also attend grade 11 lessons, because I try by all means to do those chapters which include everyone in all grades. Only when I need specifically for grade 10 learners, I'm going to tell and say only grade 10 learners are invited. Grade 11 and 12s not invited. Otherwise, if you like, you can still attend. So, for example, Doppler effect, it could be a physical science chapter which is only being done in grade 12. So you can see this. It's not necessary for grade 12, grade 11s and 10s to attend. You can only attend out of interest if you like, but it wouldn't be a suitable lesson for you if you are in grade 10 or 11. So guys, that was just a mic check, but the story is true. Are we all on the same page? And is everything in order? Just test your mic, unmute, make a comment, mute your mic, then we continue.
Yes, sir.
Yes.
Okay, 100%. So guys, we are looking at trigonometry. Just a quick summary. I was saying in trigonometry, we are focusing on a triangle, specifically a triangle known as a right-angled triangle. So this is a triangle, guys. Why am I saying this is a triangle? Is because I see we've got side 1, side 2, side 3. So in trigonometry, we study the sides and angles of a triangle. So this is a triangle, but what we are looking at in trigonometry is what we call a right-angled triangle. For it to be a right-angled triangle, we must be told exactly where is the right angle. So the right angle, obviously, we know this is a vertical line, this is a horizontal line. So we've got two perpendicular lines, which means they form a 90-degree angle there. So let's say, for example, this is A, this is B, this is C. So this is called triangle of A, B, and C. So this is the name of that triangle. So if it was, let's say, D, E, F, it was going to be a triangle of D, E, F. So We said in triangle, how do you see a triangle? A triangle has got 3 sides and 3 angles. So 3 sides and 3 angles. So what are those angles? The first one is that angle which is 90 degrees. The second angle is there, and the third angle is that one over there. In terms of the sides, we've got the first side, we can refer to it as side AB, notice in capital letters. So sides are represented in capital letters. Another side is BC in capital letters. Remember, guys, be smart when you represent these letters. I've always been saying follow the alphabetical order. Don't call that side CB. Don't call that side BA, but rather call it BC, because B comes first, C comes second. Then that one is going to be AB. So try to organize your work. So now let's see another side between A and C. Obviously A comes first, then that side we refer to it as AC. Very, very much important, ladies and gentlemen. So this is all regarding the sides. So now let's talk about the angles. How do we represent an angle? So if we want to talk about angle A, they can say angle A. Then you know they are talking about angle A. Otherwise, they can just say A and that small line cap over there. That means this is the angle that they are talking about. So now, remember, guys, we said we've got 3 sides which are given names. I just don't want to confuse you guys on this one, but for now, let's talk about a triangle where we know that this is A over there, which is alpha. So I'm just going to explain afterwards in terms of the C angle and again the 90-degree angle. So let's see. We said we've got 3 sides, guys. Do you know what are the names of those 3 sides? Don't tell which side is which. Just tell me what are those 3 names. Do you still remember, guys?
Yes, it's opposite, and adjacent.
Yes.
Lerato, in most cases, your mic, your voice, it's a bit low.
Sir, is it opposite, hypotenuse, and adjacent?
100%. So those are the sides. Those are the sides that we normally work with. So it's opposite, adjacent, and hypotenuse. So you need to be able to identify those sides on a triangle. So I said, how do you notice a hypotenuse? Hypotenuse is always opposite to the 90-degree angle. So that means that side is hypotenuse. And again, what do we know about hypotenuse? Hypotenuse is the longest side. What does it mean? It means if you are given this side being 2, that side being 4, then hypotenuse has to be a side which is longer than both of these, or which is longer than the longest side between these two. So if we've got 2 centimeter, we have 7 centimeter, then hypotenuse has to be bigger than a 7 centimeter. If you calculate your hypotenuse and you notice it's smaller than those values, then you know you made a mistake somewhere. So now, how do you notice let's say adjacent, guys? So just follow that order. Start with hypotenuse, look for adjacent. I said because of that angle, can you see that thing is A, even though it's actually alpha? So I normally use alpha. Let me say I used to use alpha to always remind me which side is adjacent. So to me, that alpha, it actually represented adjacent, even though alpha is an angle like theta, beta, or whatever angle. So that means this side, which is closer to that angle alpha, it's my adjacent side. So it doesn't matter whether there is angle theta or beta or whatever, or angle A. So in my case, I used to just imagine that angle being alpha so that I'm able to identify which side is my adjacent. Therefore, that means this side is obviously going to be opposite, because once you fail to identify your sides, then you are most likely to get incorrect answers when you perform calculation. So remember, guys, this is just a revision of what we've done on our previous lessons. So just in case if you missed those lessons, I'm going to post them tomorrow on my website, and I'll share the link in the group. Just make sure to catch up, because as we go deeper, you will enjoy the lessons if you catch up. Otherwise, if you attend lessons, that's good. Make sure that you don't miss any of my lessons. Ladies and gentlemen, let me now continue. So, in terms of angle B, we know it's going to be represented as angle B, then you know it's angle B. Otherwise, they can just say B that. And we know B is our 90-degree angle. What does that 90-degree angle tell us? It tells us that this is a right-angled triangle. For it to be a right-angled triangle, it means we can use the trig ratios to solve problems related to this triangle. Ladies and gentlemen, what are those 3 trig ratios? Just mention your name, say the names, mute your mic.
Talk to us, sir.
LB, sine, cos, and tan.
100%. So guys, I just remembered something. It's very, very much important, guys. It's very, very much important that you follow instructions. So if they say, what is your surname? Don't mention your name, guys. Mention your surname, because the question said, what is your surname? So this is going to help you guys when I teach you on how to identify the cream of the question, especially in physical sciences. I emphasize points where I teach you how to identify the cream of the question. So in short, the cream of the question is that weight or those weights when removed from the question, the whole of that question remains senseless. So guys, please make sure that if the information is sent in the group, you read and follow instructions. Guys, make sure that in case if a comment is made in the lesson, you follow instructions. It's better to ask for the question to be repeated, then you will correctly answer the question. LB, thank you very much. So those trig ratios, they are 3. So it's sine, it's cos, it's tan. So always let's follow this order. Let's firstly start with sine, cos, then tan. You will notice at a later stage why it's important to just represent them in that order. So the third angle obviously is angle C, which can also be represented as angle C in that way. So I assume at this point in time, you are now aware of a right angle triangle, all the sides associated with a right angled triangle, and also to label the sides, and you are aware of the angle. So something that I think is worth mentioning is that, for example, if you know what that angle is, even if you don't know, but what matters the most is that the sum of the interior angles of a triangle must sum up to 180 degrees. Most importantly, guys, when we're dealing with angles, if it's 91 and it's an angle, don't just say 91, but say 91 degrees. And Rato said, make sure that your calculator is always in degrees so that you get correct answers. So ladies and gentlemen, before I make a summary on a CAS diagram, is there someone who's got a question, or is that part clear to everyone?
Sir,
Yes.
sir, I have a question. Sir, so we only have 3 trig ratios.
Okay. That's a good question. So we have three main trig ratios. And those three main trig ratios, it's sine, cos, and tan. The other trig ratios, what do you call them? I think it's, what is it, guys? Cosec, sec, and cot. Yes, those are what we call the reciprocals. So those are what we call the reciprocals. Those are the inverse of the main three trig ratios. So these three are what we call the main trig ratios. So for sine, we know what is it? It's cosec. So it's cosec. We know for cos, it's sec. We know for tan is cot. So these are not the trig ratios, but we call them reciprocals. So a reciprocal is the same thing as inverse. Is the same thing as inverse. What is inverse? Inverse is 1 over whatever. This is inverse. So let me just try to remove part of what I've explained to just make sure that it makes sense to everyone. Guys, this is whatever. So what is reciprocal of this thing? The reciprocal of this thing, or the inverse of this thing, is 1 over whatever. Why did I say whatever? Whatever could be cos. It could be tan. It could be a. It could be 2x. It could be whatever. So when they say what is the inverse of this thing, whatever that it is, guys, when they say, or the question says, what is the inverse? If it's cos, then it's 1 over cos. This is the inverse. If it's tan, then it's 1 over tan. This is the inverse. If it's 2x, then 1 over 2x is the inverse of 2x. I'm not sure if it makes sense to everyone, guys.
May I ask, sine over cos?
No, it makes sense. Yeah, it does make sense.
Someone said it makes sense. The first lady, I'm not sure if you wanted to ask your question, but just confirm for me if it made sense or if you wanted to ask your question.
Wanted to ask a question.
Okay,
Sine over cos.
go for it.
Cot. Sine over cos. Is it still cot?
You're asking if sine over cot is still cot.
Sine over cos.
Oh, you're asking if sine over cos is still cot. Okay, just to further my explanation, guys, I think I will indirectly answer your question. So the reason why, if I say we've got 2x, the inverse of this is 1 over 2x, it's because at the bottom there you have that invisible one. So the inverse, it's more like you write the denominator in the denominator, then you write the numerator in the denominator position. So let's say you have 2 over 4. So the inverse of this thing is actually 4 over 2. That's it. So if you have cos x over sine x, the inverse of this thing, you just write that in that position, this in this position. Then it's sine x over cos x. So this is the inverse of that, or otherwise this is the inverse of that. So remember, guys, this one does not form part of our lesson. I was just trying to answer Lerato's question where she was asking if we've got only 3 trig ratios. And answer to that question, it's a big yes. So Cosec, sec, and cot, those are what we call the reciprocals. So otherwise, those are what we call the inverse of the main trig ratios. Does it make sense now?
Yes.
Okay, 100%. So now let's quickly move to that diagram. We said this is what we call a Cartesian plane. Why is it a Cartesian plane? It's because we see the x-axis and the y-axis. Therefore, we've got a cast diagram represented on a Cartesian plane. So what is it? I hope I got it correctly. Cast diagram. So we know all trig ratios in the first quadrant, which is quadrant 1, are positive. Then it's only sign in the second quadrant which is a positive. So it's only what is a tan in quadrant 3, which is positive. It's only what is it cos, which is positive in quadrant number 4. So in terms of the angles, we know this is 0, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. And we said we represent angles formed with a line starting from the origin, radiating in that direction, and we call that point the initial point, and this is the terminal side. Therefore, you've got a vertical line there, which is forming a right-angled triangle. So I hope you guys still remember this part to say this angle which is formed is within quadrant number 2. Otherwise, if you've got an angle which falls in quadrant which is between 90 and 180, we represent the diagram like that, forming 190 degrees over there. And remember, this is your R, which is positive, always positive. Your R, always positive. It's only on this side where we have negative X, but positive Y, because it's from the origin up to there, 100%. Same applies there. We still have that negative X. It's only Y which is negative in this side, and this is your positive R, and then you have that. What is this, guys? This is still negative Y, but in this case, you've got positive X value. So remember, I'm a bit quick on this one because I've done a full lesson. I think it was yesterday where I was teaching all of this. So now, if there's no one who's got a question, then we move to the business of the day, which is reduction formulas. So guys, are we ready to now move to the business of the day?
Yes.
That's if we all understand that there's no one who's got a question. Guys?
Continue.
Okay, 100%. So let me just quickly get something to explain what we'll be looking at in today's lesson. So let me remove all of this and say we'll be looking at reduction formula. A reduction formula. So have you guys done this part already at your schools?
Yes, sir.
We are in the middle.
Yes, we did.
Okay, some they did, some are in the middle. So just in case if you feel like there's some important information that needs to be discussed in this lesson, as I ask if there's someone who's got a question, if it's not a question but a comment, just make sure to share with the rest of us, because what I like about these group lessons is because some of you guys have got very powerful teachers who dish out important information, of which when you share with the rest of us in class, when we get to that stage, we will have a better understanding. So it's not only a question which is expected, but otherwise, in case if you've got a question, I mean a comment, you can still make a comment. So guys, reduction formulae are used to reduce the trig ratios of any angle 2 trig ratio of an angle which is an acute angle. So that is the definition of a reduction formulae in short. Formulae. So always make these funny mistakes, but I'm sure that you will correct it when you write your notes. So, ladies and gentlemen, what are we saying when we talk about reduction formula? Let me just say it for the last time. Reduction formulae are used to reduce trig ratio of any angle to trig ratio of an acute angle. So remember, we said on a Cartesian plane, this side is called acute angle. Why is it acute angle? Because we have angles which are less than 90 degrees from 0 degrees. So all angles formed here are what we call acute angles. I hope you remember that very well. And this side, what we call this side, guys, is it obtuse?
Yes, sir.
So do you still remember what is this side?
In the third quadrant, sir.
Third and fourth.
It reflects in the third quadrant.
It's
Reflects in the third quadrant, and then that one.
So I think it's a revolution on the fourth one.
Okay, thanks very much. So we've got acute, obtuse, what is it? Reflect, and then revolution. So a reduction formula, we are trying to take all the angles which have formed from 90 degrees up to 360 degrees. We are trying to reduce them to acute angles. So it's more like if you are given let's say 219 degrees, ask yourself this question: under which quadrant that does 219 degrees fall? Let's say there it's 180 degrees, this is 270, so it falls somewhere in that quadrant. Can you see? So we want to use reduction formulae to reduce this angle from that quadrant to the acute angle, or to that quadrant, which is the first quadrant. So that's a definition of reduction formulae as I try to explain it using 219. So that means if you are given a 91 as an angle, you know 91, it falls in there. So we want to reduce it such that we take it back to acute angle. If you are given 290 as an angle, you know 290 degrees, it falls in quadrant number 4. So we use reduction formula to reduce it to an angle which is less than 90 degrees, which falls into that quadrant. So I'm going to just explain it for the first time. So we say reduction formulae are used to reduce the trigonometric ratio of any angle to the trigonometric ratio of an acute angle. So guys, does that part make sense?
Yes, sir.
Sir, can you repeat the definition?
Okay, or maybe how about I say I will write this definition in the group so that everyone has it, because I know some of you guys, you might be writing some notes. So just so that we save time, can I then write that definition in the group and share it with everyone? Is it fine?
Yes, sir.
Yes, sir.
Yes, sir. Can.
Okay, that's fine. Therefore, let's now refer to that information that I sent in the group. So obviously, we said when we're dealing with reduction formulae. We want to reduce all the angles to that first quadrant. So obviously, if we have an angle which is in the first quadrant, there is no need for us to apply a reduction formula. But now, what if we've got an angle which falls in that quadrant? In terms of the coordinates, we know, are we having a positive or a negative x value, and what about the y value in the second quadrant?
Is negative and the y value is positive.
So we are having negative x value and a positive y value. So let's say, for example, we've got a sine beta, and this angle, it actually falls in quadrant number 2. Let's say again we've got let's make it a cos, and say we've got cos beta, and this angle also, it falls in quadrant number 2. And again we've got tan beta, this angle again falls in quadrant number 2. Let's try to then reduce or use the reduction formula to reduce that angle which falls in that quadrant, to reduce it to fall in that angle of, or maybe let's say, in quadrant number 1. So obviously, we know that this is 180 degrees over there. This is 90 degrees. And again, what else do we have? We've got 0 degrees, 270 degrees, 300 and what is it? 360 degrees. So for us to reduce that particular angle, maybe can someone just mention any angle which falls between 90 and 180? Let's say maybe 100.
150 degrees.
Okay, 150 degrees. Yes, 150 degrees. Let's say 100 degrees. Let's say 130 degrees. So let's maybe use those angles. So can you see, for us to have an angle which is an acute angle, we can say sine of 180 degrees minus, let's say, a certain angle. And this angle must be less than 90. So if we have 150 as our angle there, so what will this angle be?
135. 30, sorry.
30. So can you see now, 30 degrees, it falls within the first quadrant. So for now, guys, that is the most important part that we are interested in. We just want to know which angle, when we say 180 minus that particular angle, then that particular angle is going to be less than 90, or is going to fall within the first quadrant. So that angle is 100 there. So if it's 100, we can maybe say cos into what is it? 180 degrees minus. What will that angle be? Same for tan.
80.
So it's going to be 80 degrees. So same goes for tan. This is 130. We're going to have 180 degrees minus what is it going to be?
50.
50 degrees. Yes, 100%. It's going to be 50 degrees. So I'm not sure if so far we are all on the same page before I continue, guys? So let's now write a summary of the reduction formulas of angles which fall in the second quadrant. So that means if you have sine, or if you use the 180 degrees minus theta, then this is the same as sine theta. But now the question is, are we going to have a positive or negative sine angle?
It's going to be positive.
It's going to be positive. I hope everyone remembers very well that in the second quadrant, sine is positive. So that's why you are able to tell if sine is positive or negative. So now, let's see again. In terms of cos, if we use 180 degrees, let's say minus angle, one thing for sure we know is going to be cos angle. But now, is it going to be positive or negative?
Negative.
100%. So we are going to have negative cos angle. So again, guys, let's see. So in short, I'm very much happy that you guys are aware of this information. So in short, it means the sine, it tells us more about the quadrant. And then the angle, obviously, it's an angle which is reduced to an angle which is in the first quadrant, in quadrant number 1. So what about tan, guys?
It's negative.
A negative.
So it's going to be tan negative angle. So that means 180 minus angle, 180 minus angle. In short, it actually tells us more about the quadrant, to say here we are dealing with quadrant number 2. That's all that you need to know, guys. So I hope we are all on the same part, all on the same page on that one. So I'm going to remove all of that. Let's do a bit of discussion regarding quadrant number 3. So let me just draw that. The same quadrant number 3, we are obviously going to have something similar to that. In terms of the coordinates, can someone tell what are we having there?
Negative x value and positive y.
So we're going to have negative x value, negative y value. So remember, guys, in this case, let's also do the same, starting with sine. So in this case, we've got, let's say it's sine beta. But for this angle, it means this is an angle which falls, this is 180 degrees, this is 270 degrees, 360 degrees. So this angle falls between 180 and 270. Someone to guess that angle, please. Angle beta. What angle can we use there? And then cos beta. Guess an angle. Tan beta. Also, just tell me which angle can we use there. So let me guess. Let's say 200. And again, let's say 184 degrees. In this one, guys, are we all on the same page in terms of what I'm doing there? I'm just guessing an angle which is between 180 and 270. Maybe. Okay, so someone guessed an angle. It's fine. Thanks very much for that. So now, in this quadrant, guys, that means when we make comments, so we first start with the sign. Then after the sign, we use a trig ratio, which could be sine, which could be cos, which could be tan. Then from there, we write the angle, which is acute angle. So let's see. In this case, obviously, because in this case, we've got an angle which falls in quadrant number 3. So it's more like we use reference of that 180 line or that horizontal line. So that means we are going to have sine angle being 180 degrees. So it's going to be a plus because that angle, it falls in quadrant number 3. So it's going to be 180 plus that certain angle. So this is the 180 degree angle, which is that one. Then we say plus that small angle, which is going to be that additional angle there, which is going to be, let's say, plus theta. So in this case, guys, are we having
Wait,
a
so
positive?
I have a question.
A question, yes.
Are we looking for an angle that's going to give us like 200, like 180 plus 20?
Yes. So remember, the reason why we say 180 plus that angle, in short, we are saying 180 plus that small angle, which is less than 90, which falls in quadrant number 1. So for everything that we do, we just want to say maybe a 180 minus that small angle, 180 plus that small angle. If we are on 360, then it could be 360 minus that small angle. I'm not sure if it makes sense now.
Yes.
So, but be careful of something.
Sense.
In this case, you must first make a comment on the sine, trig ratio, then that angle there. So my question is, in terms of the sine, is sine negative or positive in that quadrant? Are we having a positive or negative sign?
Negative.
100%. So that means we've got negative sine angle. Then again, let's try to have a look at this one. So let's see, guys. Obviously, it means we're going to have cos of into 180 degrees plus that certain angle. So what sign are we having here, guys?
Negative cos.
Negative cos.
Negative cos angle, 100%. So now let's check something, guys. What about tan?
Positive.
Tan is positive.
Positive.
Tan.
I'm going to have tan. No, the positive is not yet there. I'm not sure if there's someone who's got a question, guys. Just make sure that you speak louder so that I'm able to hear if it's a question. So you guys are saying it's positive tan angle. So I want to make you guys aware of something. So is that a question?
Yes.
Guys, was that a question? Remember, if you're not asking a question, make sure your mic is muted. Andile, can you mute your mic?
And at theta at the same time. Are you not
Someone is making a comment and is breaking, but it's fine. For now, let me continue. Maybe before the end of this lesson, just make sure to ask that question again. But I want to make you aware of something very, very much important, guys. So I want to teach you how to prove if your simplification or your step, whatever that you did, is wrong or correct, especially in terms of the sign. So let me just have that over there. So guys, remember, this thing is the same as sine of 200 degrees. Do you guys agree with me on that one?
Yes, sir.
Yes.
100%. And you said sine 280 degrees is the same as sine of 180 degrees plus a certain angle. What is that certain angle, guys?
Plus 20.
So you said that angle is 20. Remember, let's say it's 20 degrees. So now, this is the interesting part that I want you guys to notice. So you said this thing, what is it, guys? Is the same as what?
Like
negative sine 24.
Negative sine 20 degrees. So, guys, punch this on a calculator. Whatever answer that you get, write it down and say it's equals to. Punch all of this on your calculator. Whatever answer that you get, write it down. Punch this on a calculator. Whatever answer that you get, write it down. So for you to be sure that all of this is correct, you must get same answer. Same answer. Same answer. If you get a negative answer, also here it has to be negative answer. If you get a positive answer, it has to be a positive answer everywhere. But if for some reason there, maybe you get a negative answer and there you get positive answers, then you know you made a mistake somewhere. And in most cases, is the sign that you get it wrong. Are you getting the same answer, guys?
Yes, sir.
Yeah,
100%.
all of it's the same answer.
So does it make sense in terms of how to prove if your simplification is correct?
Yes, it does.
So
Yeah,
for the
yes,
last time,
sir, it does.
Let's do for tan 217. What is tan 217? Then what will that angle be?
It's going to be 37.
Someone is saying it's going to be 37 degrees. Remember to mention that degrees. So is it true? Is it going to be 37 degrees?
Yes.
Okay, that means this is going to
so
be
it's 37 degrees.
Degrees. Then punch that, punch this, punch that. Expect to get a positive answer because you said finally your answer has to be positive. So just comment if you get the same answer. If you get a different answer, also comment. Guys, I would like if you guys, when you make comments, sometimes just mention your name, then the answer. I just want to make sure that we know each other, because as I'm doing this lesson, I'm not able to see who has attended this lesson. So in the future, it would be nice to just call out your name and you give an answer. So just make sure that we know each other.
I'm getting a negative answer for all of it.
LB's getting a negative answer. Someone else who also got a negative answer.
This is Cindy, so I'm getting a positive answer.
Okay, let me write it again. What was that number again? I think I forgot what it was, but I think it was maybe, what was it? What was this angle?
It was 217.
217. So we said this should be tan LB. Let's you and I communicate. Whoever got negative, you can just participate by only listening. So we said it's going to be 180. Is it going to be a plus or a minus?
It's a plus.
It's a plus. Remember, guys, I'm only communicating with LB and whoever who got a negative. So LB, here comes a question. does this fall? Okay, in which quadrant does this fall? Does this angle fall? Third quadrant. So, what makes you to say it falls in third quadrant?
So I'm looking at the trig ratio term. It's in the third quadrant, unless you're talking about the angle 180.
So, okay, I assume it's LB again. So LB, the question is, you say it falls in third quadrant. So what makes you to say it falls in third quadrant?
It's 180.
So I was saying that I'm looking at the trig ratio, which is tan, because it's in the third quadrant.
Oh, okay, no, I see. So LB and everyone else, the reason you say it falls in a certain quadrant is because of that sign and that angle. So remember, that means we've got 180 degrees there. So for an angle to fall in that second quadrant is going to be 180 minus. It's going to be 180 degrees minus theta. So that means LB, it's any angle less than 180 degrees. But if it's an angle which falls in quadrant number 3, it means from 180 degrees you add. Can you see? So that means in this quadrant you have 180 degrees plus an angle. So here, I think it should be 360 degrees minus angle. So this 360 and that minus is what tells you in which quadrant the angle falls. I'm not sure, LB, if it now makes sense.
Yes, sir, it makes sense.
100%. So now let's see. You said it falls in third quadrant. So obviously, are we going to have a positive or a negative answer there? What is that angle again?
It was 217.
No, this one.
37 degrees.
37 degrees. So that means we are going to have tan 37 degrees. And you said it's positive. So what I'm saying, LB and everyone else who got a negative, is that if you have this, and this is how you apply the reduction formula, and you end up having a positive answer. So that means when you punch a tan 180 degrees plus 37 degrees, it must give you that same answer, which should be a positive answer. So I'm not sure which answer you get when you punch tan 37 degrees, but what matters the most is that it has to be a positive answer. Then now, LB, you can try
to
punch
I saw where
it
I
for
went wrong. I used the
you noticed your
negative
mistake,
side.
ne? Okay, so that means everyone who got a negative answer, it could be because somewhere you made a mistake on your calculation. Are we all happy so far, guys?
Yes.
Yes, sir.
Yes, sir.
Okay, so let's try to now have a look at an angle which falls in third quadrant. So let's see. Obviously, you're firstly going to have a Cartesian plane. Is that a question? Is there someone who's got a question? In terms of the coordinates, what are we having there?
Negative x, negative y, and positive x.
Positive x, negative y, 100%. So let's see, we have that cast diagram. Okay, so in that case, let's also make a guess of an angle which falls in there. So let's maybe start with sine, let's say beta. What could be that angle, guys? Can we guess an angle, guys?
300 degrees.
Someone said, did someone say 300 degrees? And then the other one, let's say maybe 279 degrees. And then the other one, let's maybe say 300 and what? 13. Okay, thanks. 313. Okay, so in this case, it's more like we have signed that. So let's reduce it. In reducing that, we are going to have a 360 degrees minus an angle. So remember, we are making reference along that line. So for these two quadrant 2 and quadrant 3, so we used 180 degrees minus angle for angles falling in that quadrant. Then we used 180 degrees plus angle for those that are falling in quadrant 3. So in quadrant number 4, we are going to use 360 degrees minus angle. So guys, what can you say about that angle? Yes, someone has got a question?
Wait, I'll be speaking. Wait, what is cos beta and tan beta there? The angle.
Cos theta, this is 279 degrees. This is 313 degrees.
It's 279.
Yes, 279.
And then the tan beta?
313.
303.
No, 313. 330.
Okay, thank you.
Okay, so let's see guys. What are we doing? Oh, I was asking a question to say, what do we know about that angle? So this is what we know, guys. It has to be an acute angle. What is an acute angle? It's an angle which is between 0 degrees and 90 degrees, which falls under that quadrant. So let's now see. This is 300. So what will that angle be? Obviously, it's going to be, let's say, angle theta. And the question now is, are we going to have a positive or a sign value?
Karabo, negative, sir.
Negative.
Say it's negative.
Then what am I writing? So it's negative sign. What is that number there? Or that angle?
Negative sign 60.
Negative sign 60 degrees, 100%. So this one, we are having a cos of angle. The angle is 360 degrees minus that. So also tell me, what are we writing there?
Negative cos. Positive cos.
It's positive cos.
Positive cos. What is it? What is that angle?
81.
Positive cos 81 degrees. And then in terms of tan, what is it?
It's negative tan.
It's negative tan 47 degrees.
Negative tan 47 degrees. So, are you guys happy in terms of how to prove if your answer is wrong or correct?
So,
Mm-hmm.
For tan, it's not supposed to be 47, it's supposed to be 30. Because 360 minus 330 is giving us 30, not 47.
Did someone say 47 or that's 47? Where
Wait,
did I get
isn't
that?
the angle 313, like 360 minus 313 is going to give us 47?
Yeah, she's
So
wrong.
this is
I don't
this is
understand. Wait, isn't the angle 313?
Oh, sorry
yes,
guys,
it's
I thought it was
313.
330.
Okay,
No,
so
it's
47 is correct,
13.
ne?
Yes.
Okay, 100%. So that means I just wanted to confirm something, guys. Can LB punch all of that to check if it's correct? Lerato punch all of that to check if it's correct. Who else has attended the lesson? Can someone mention their name? I think Lebo must be there. Lebo, are you there? Punch all of that on your calculator and just let us know if it's correct by commenting. Everyone else also comment. Just wait for someone. If they mention something which is an incorrect answer, then tell us what is the correct answer.
A negative sign 60 until negative 0.86.
Which one? Negative sign 360, negative sign 60. Which answer are you getting?
Negative 0.86.
Okay, so you're getting a negative answer. Okay, no, that's fine. Whoever gets an answer, just mention it. If it's wrong, just let us know so that we are aware if it's wrong or correct.
The cos beta I'm getting 0.15. 0.16. If I'm converting it.
Done.
So we are all good getting correct answers, isn't it?
Yes.
Bhutan is negative 1.072.
Okay.
Yeah,
So
so the cos beta is correct.
It's positive 0.156.
Yeah, it's positive.
okay, so that means we are getting correct values. So as we approach the end of today's lesson, guys, what I want us to do now is to just interpret that exercise that I sent in the group. That's actually what I want us to just do, because if we are able to interpret this information, then it puts us in a good position to easily remember this stuff when we are solving exam type of questions. But I think so far it makes sense. We are all on the same page, isn't it?
Yes, sir.
Yes.
Okay, so in short, a summary of what we have done. Function values, the function values, let me call them the function values. So do you guys agree that most of what we've been doing, we were using a 180 degrees plus or minus angle theta, and again we used 360 degrees minus angle. Do you guys agree with me on that one?
Yes.
Yes, sir.
Okay, so you can just write it as part of your notes. So let's now try to interpret those the exercise that I sent in the group without us having to draw a Cartesian plane. So remember, guys, you might be in exam room. You don't have time to be writing or drawing a Cartesian plane, label the cast diagram and everything. You must have everything in your head. So trigonometry, guys, it's not really that much complicated. You will see even when we do those identities and everything, they are not really that much complicated, because I notice most of you guys have got the basics already, which is a good indication that when we start, you will never fall behind. So quickly, I'm going to just be choosing names. 180 degrees plus a angle. So this is what I want us to be doing, guys. I'm going to be doing it for the first few times. So this is a trig ratio sine angle 180 plus theta. So this is how you interpret it, guys. Let's see. This thing, the whole of this, is an angle. And this angle, it falls in third quadrant. Why do I say it falls in third quadrant? It's because it's 180 degrees plus an angle. And that angle, it should be an acute angle. What does it mean when it's an acute angle? It's an angle which falls between, what is it? It falls between 0 and 90 degrees. And again, in this third quadrant, sine, it's a negative. Do you guys agree with everything that I've explained?
Yes, sir.
Okay, 100%. Let's try a different one. So I think to make it easy, I'm just going to be explaining all of these things. If it's wrong, just say something it's not explained correctly. So okay, let me just do this one. Let's say cos into 180 degrees, and then what was that? Is minus angle. Okay, so this is cos 180 degrees minus angle. So this one, it falls in quadrant number 4. And again, in quadrant number 4, cos is negative. So that means we end up having negative cos angle. And that angle is obtuse angle, which means that angle, it falls between 90 degrees and 270 degrees. Correct or wrong?
Yeah, it's not quadrant 4.
It's quadrant 2, sir.
Quadrant 4, cos is positive.
It's not quadrant 4, it's quadrant 2.
Cos is the second quadrant.
So you guys are saying it's quadrant 2. So
180 minus theta decreases.
No, is it not quadrant 4? Since it's 180 minus 2.
Okay, 100%. It falls under quadrant 2. Then in terms of the angle, is that wrong or correct?
It must be 180.
180 to 90. 90 to 180, yeah.
100%. So,
90 and 180.
guys, this thing, when you see something written like that, it means between. So this thing, it means between. So between which angles you are right is between a 90-degree angle and the 180-degree angle. So what I said about that angle, am I correct or is it wrong?
Which is wrong?
Cause and it's negative. It's correct.
So I said that angle is an obtuse angle.
You are correct, sir.
Yeah, it's correct. It's correct. Yeah.
Who said I'm correct? Who said I'm wrong? Spamandla?
Karabo.
Correct.
Spamandla correct. Karabo?
Correct.
Okay, so I'm going to explain, guys. Remember, we have a Cartesian plane. These angles which are between 0 degrees and 90 degrees. What do we call those angles, Larat?
Acute angles.
Acute angles. Angles which are between 90 and 180, what do we call those angles?
Obtuse angles.
Obtuse angles. And then here you said reflex. Did you say reflex?
Yes, sir.
Yes, sir.
Okay. A reflex angle. Someone had revolution angles. Someone has got a question, so you can ask your question.
Wait, it's Alvi. Wait, in quadrant 4, when we are supposed to like reduce an angle, isn't supposed to be like 360 minus an acute angle?
Yes, that's correct. That's correct. So in answering my question, guys, for the last time, am I correct in saying, okay, you corrected me on those, but now in terms of the angle, is it an obtuse angle, that one?
Quadrant 4 is
Yes,
positive because quadrant 2 is
Okay,
negative.
so it's fine, guys. I welcome all your attempts, but I'm going to then now explain that part. It's not obtuse angle, but it's acute angle. Let me just remove all of this and explain. Just make sure that you fully understand. Remember, guys, it takes us back to the definition of a reduction formula. We say the moment you say, let's see, we said the moment you say 180 degrees, it's either you plus or you minus depending on the angle. LB, we said 360 degrees minus an angle. The moment you see yourself using this, then you know you are using a reduction formula. So the main aim of a reduction formula, we said, is to reduce that trig ratio angle to an acute angle. I'll just write again that definition in the group. So that means if you have 217 degrees, you want an angle which can be worked out with a, what is it, guys? This one, it falls under which quadrant? Is it third? I think it's third, where it's going to be 180
It's
degrees
third quadrant.
plus angle. So this is the angle which is going to be an acute angle. It doesn't matter whether it's a sine there, whether it's cos there, whether it's tan there. So this part is to guide you in terms of the sign, whether it's going to be a positive sign or a negative sign. Then this part, it guides you in terms of the angle. Which angle is that one over there? And this angle, guys, always it has to be an acute angle. What is an acute angle? An acute angle is that angle that falls in the first quadrant, which is between 0 degrees and 90 degrees. Does it make sense now, guys?
Yes, sir.
Yes, sir.
Yes, sir. Wait, so I have a question. So wait, if it's in like quadrant 3, so we're going to say 180 plus an acute angle.
Yes, if it's in quadrant number 3. So you want to see why you say plus.
Yes,
Do you
sir.
want to see? Okay, so you have 0 line and there it's 180 degrees. So any angle that falls there is going to be in that quadrant. So this is any angle which falls in quadrant number 3. For example, if that angle maybe it's somewhere there, it doesn't matter whether it's somewhere there, it's somewhere there, it's somewhere there, that line. For as long as it falls in quadrant number 3. So for the sake of explaining it easily, we just do it that way. So this is the angle LB. It's 180 degrees. Can you see? So you have to add another smaller angle so that it takes you to that line, which is this angle. So this is the 180. This line is for the 180 degrees, and then that smaller line is for that angle. So that is why you you add. Let me actually write it there so that it's clear. So this is that theta there. So that is why if it falls there, you're going to say 180 plus that smaller angle. I'm just not sure if it makes sense, even though my marker is disappointing me there. Okay, just indicate if it makes sense why you are adding. So let's see why you would subtract. So let's say you have an angle which falls in that quadrant. So that means because we use this line as a reference line, this is 180 degrees. So that is a 180 degrees. But the angle that we are looking at, you have to minus from that 180 up to there. So this is that particular angle, because obviously it has to be 180 degrees minus a certain angle, which should be an angle that falls in quadrant number 2. If it falls in quadrant number 3, it has to be this 180 plus a certain angle that takes you into this quadrant. So in quadrant number 3, in Q3, means you're going to have something similar to that, and this is the angle. So that means in this case, you're going to say 360, which is that, remember, circle is 360 degrees. Then you need to go back. When you go back, you subtract. That's why I say 360 degrees minus a smaller angle. So this angle, it has to be an acute angle. So that is why we say we use reduction formulas to convert from that bigger angle to an acute angle. LB, I'm not sure if you're happy with that explanation.
Yes, sir. Thank you. It makes sense.
Okay, 100%. So, guys, I think this should bring us to the end of our lesson for today. But let me just quickly do something of which I think it might blow your mind, even though I notice I'm remaining with 6%, but I'm just going to quickly do this one. Let's say we have a cos 180 degrees minus angle theta there. I want to explain to you why. What is this one, guys? In short, can someone quickly tell us what is that one? The final answer, what is it? So it falls in second quadrant.
Negative
It's negative
cos
cos
theta.
angle, 100%. So I want to show you something. Remember, in maths, we know very well that if you've got this thing and you have brackets inside, you say that times that, that times that. Do you agree?
Yes, it distributes.
Which means we are going to have cos of 180 degrees minus a cos of that angle. Do you guys agree with me on that one?
Yes, sir.
What is cos of 180 degrees? I'm sure you're going to find 0. Then this is minus cos of angle. So because it's 0, 0 is just nothing. No need to write. Which one is
It's
it? Is it
negative
negative
1,
one?
sir.
Negative 1.
Check something there.
Yeah, cos of 1.
Let me do this. Let me check with a sign quickly. Sign, let's say, sign that is 0. Let me check with a tan. Wait. Tan 180. What is tan 180? It's also 0. So what I wanted to explain, it's best explained when we have got a sign. I think on our next lesson, I'm just not sure if we'll continue with maths or physics in the afternoon. I think maybe we can just give me a suggestion on that one. Then I will fully explain what I wanted to explain on our next lesson, because I noticed I'm left with 4%. So guys, just with a comment, I'll continue on this part on our next lesson. But quickly on our next lesson, probably at 4, are we doing physics or is it maths? Are we continuing with this or are we doing physics?
Maths.
Second, please do physics.
Let's do
Physics,
physics.
can you please do physics?
Okay. Okay. Let's say here's an instruction, guys. If you attended today's lesson, raise your hand, and then also I will see. Let me just leave it. I will see in terms of we can do physics or maths. But otherwise, if we do maths, we'll continue from this. If we do physics, then I'll see which chapter we can start with. So I know a chapter which is being done in grade 11 and 12 is work, energy, and power, isn't it? And I know Doppler effect is only in metric. So do you guys in grade 11 do work, energy, and power?
No, I didn't do it.
Not yet, sir.
No, sir, we are in chemist.
Okay, then it's fine. Remember, I said text me via inbox to mention your name. I think I said grade and the chapter that you've already done and you don't understand. So just make sure to make that comment via inbox, guys, not in the group. I just want to try and keep the group with less text as possible. So otherwise, if everyone comments in the group, then we have names, whatever. So just via inbox, tell me a name, subject, then that chapter. Then I'll make an announcement in the group in terms of whether we'll be doing physics or mathematics, but we're most likely to be doing physics because we've done a lot of lessons on physics. So next time when we do maths, we'll continue from what we've done today. But on our next lesson, I think we'll be trying to do those exam type of problems. So guys, were you happy with today's lesson, and can we now say let's meet on our next lesson?
Yes, sir.
Yes, sir.
Yes, sir.
Okay guys, thanks for joining. Then I'll see you guys on our next lesson. I'll make an announcement in the group.